unbedenklich, Spektrum. Ich muss ihn, wie gesagt, nicht vorstellen. Fefe.
Yeah, good morning. I'm happy the audience, such a lot of audience here. This talk is, well, I have to do some expectation management because last year I submitted a different talk and about TCP minimization, and it would be a little bit too technical as a programmer. That one was declined, so I tried again this year. But I didn't want to make the assumption that I want to annoy the people, so I just handed in another talk. That's the one that got accepted, and I had to prepare it real quick now. So it's more like a thought process instead of a structured presentation. I hope it will be helpful anyway. So I'll just start. There are multiple ways to come to the conclusion, but I'll just let you participate here. So I started relatively early in my career, and I decided to never write software where life depends upon, and like medicine devices or nuclear power, military, no way. But then I met someone that wrote code for nuclear reactors, and he said, "Oh, that's really easy." So if the people who can't estimate their limits, then someone else would do it. That's not supposed to be a generalization. I also met someone else who wasn't like this, but there's this kind of persons. So the problem at this point is that you learn program by doing. It's not really a course you do, you just walk around and test your limits. It also means that, by definition, you don't know these limits because that's what you want to find. This also means that all the people always work on their limits. So if people write software, then they go as far as they think they can. And that means, on the contrary, that the technology that is being rolled out there is not just like well understood things, but it's these technologies that the person understood just quite, and that's a problem. And this is being made even worse, that we have like this modularity and dependency wave, that people just use modules of someone else, and without a foundation in reality, that the one who wrote this, he must know what he was doing. And that's exactly not the case. It's just like people like you and me who also did this in an explorative way. So you can think of this yourself if you do a thought experiment. You could watch this live. So let's assume that someone found a way to deal with complexity better, like modularity or object-oriented programming. And then you would hope that the software that is prescribed will be done better, in a better way. But that's not what happens. What's happened is, no, we write bigger software and, again, work on our limits. I think that's not a problem of software development. I think it's generally a problem with humans. That's what evolution made of us. And we have to learn to deal with this. So I have a theory, I call this the gradient theory. And the thesis is that humans see their environment as an optimization process, and they're looking for the lowest and the highest points. And they don't do this in a very precise way. They have to make assumptions. It's more or less random. So if it's cold, you don't just go to the radiator and just put it like you want it, and you put it on hot, and then you wait until it gets too hot, and then you turn it down again. And that's not only with radiators, it's also with cars, with driving around. If we have a map, where's the limit? Where do we have to turn? And the path there, we just ignore it, because even though it might be even not very nice. Also the choice of speed, we just accelerate until we feel unwell, and then we take a step back. If we look up something in a dictionary or in the telephone book, we make an assumption where it is, more or less, and if it's too far, we just go back. So the elementary part is we have an assumption that the map looks around here, so we have some smooth transitions. That's called gradient descent, this process. So you always try to follow the gravity to find the lowest point. But it doesn't work in two cases. The first one is if there's a cliff. When I walk over there, I can go back. And it also doesn't work well if you realize that you went too far. That's the same thing with a cliff. And the second problem is that if you can't roll back for a different reason, that's also something you have in software development. And it turns out that that's these kind of problems that people have. For example, like a 2-week trial subscription, then people forget to leave again, or drug addiction or gaming addiction. And in software development or project management, we already invested so much, we just can't go back now. Security isn't a gradient. It may look like one, but it's not. It's not. And that's probably the foundational problem of IT security. You don't realize if you went too far, you only realize it when you get hacked, and then there's no way back because the data is gone. Complexity is similarly to security also a gradient. It feels like a gradient, but it really isn't. It feels like we have everything under control, and at some point when we realize we don't, then we can't go back. Also, giving data away is also a pseudo-gradient. At the point when you realize that you gave out too much, then that's too late. So the conclusion is that complexity is evil. We realize it's too late, and we catch it too easily, and we have to do something against that. And the cost will be given away to our clients if we do it professionally, or to our users, and also to our future self. So that's why you very rarely find elderly software developers that are happy. So that's the first thought process that led me in this direction. And the second one is, for this I take out the GNU manifesto. I don't want to bash GNU in any way, but that was the original announcement. Stallman wrote, "We make Unix programs, but we won't be the same as Unix, and yeah, we'll make all improvements that are convenient." And that's a very nasty sentence. Convenient for who? But that's the approach a lot of people have that write software. Oh, we can add this real quick. And what's missing is a kind of corrective. So what kind of legacy do I put on my back right now? Then that's our hereditary sin in software development. And I think the only way to get rid of this is if you throw away the whole software, the whole module, and start again, but software just doesn't die. So working with software, I only realized it's hard if people die, because that's a corrective the system needs, and that's why software has to die. But it's not what's happening. It's a feature that things don't live forever. We have, in general, we can see this if someone wants to extend the software in order to solve a specific problem or a more general problem, then people will always try to solve the more general problem. And that's what you can see almost everywhere. There's only a very few exceptions. And I had my realization that when I looked at the project, it was just some checkout. On my own web server, I have a GDB in it, a configuration file for the GNU debugger that says, for example, call the program if you want to debug it with these parameters. And I write in there, don't use port 80, but instead use some other port like 8050. And GDB started one day to, no, I won't take this GDB init file anymore because it's in a folder that's not been agreed upon. And that's a thing to correct something after the deed. So it realized, oh well, our configuration file became so powerful, so it's been a security risk, and so they just nailed it down. They closed it up. that broke more than necessary. It was very annoying for me. You can add an automatic path, but that's when I realized it for the first time. It was a couple of years ago. I don't know exactly when. There was a similar case with Vim. That's an editor that I very often use. You can do something like put something in a commentary. The last three lines of a file, you can set some config files, for example, setting a tab stop of 4. But the parser has a security problem, so it was possible to create a file that would be executed if it's opened in Vim. That's not what they wanted to do with this feature, but that's the same problem in green. And you can generalize this problem. Generalization is good, but not in software. So we have this example here. So for example, we have a CSV file with trouble tickets. We're interested in the fourth column. For example, it looks like this. So I want to sum up the fourth column. So first I use cut. We're in Unix, so it filters it out. The first line has to go. So with the tail, we remove the first line. I can use another tool to add stuff, and then I have to compute it. But what happens if instead of one there's Fred or just a string? Then we realize, okay, cut doesn't have a problem with that. Tail as well. Tail neither and paste neither. But BC fails spectacularly. So that means even worse, BC is programmable. For example, that could be the Ackermann function, and then your PC would stand there for an hour trying to resolve the recursion. And I think it makes sense to introduce a concept here and say cut, tail, and paste are harmless, but BC is not. All right, that's a thought I had, and I thought, okay, I could make a talk about that. Although it's not sufficient. There's a couple of things of harmlessness.
So let's formulate it like this. Software is harmless if unexpected input is not leading to unexpected behavior or random outputs. So char some would be harmless or word count. So you could say use AWK. So here we don't have a problem if there's thread instead of 4. That looks better. But is it really harmless? And it turns out it's another form of not harmless, because you can have code and change the OS system. So I now have to check the code that I put in at the command line. In the industry, this is a big problem. The gaming industry now changed it to use interpreters in their games, and the business logic, not the AI, but small scripts. So they could write those small logics in a script language, and the script interpreter is Lua, and that is used because it can't do anything that you haven't explicitly allowed it. So it can't open sockets, it can't open files. You can allow that, and then you have a problem, but that is a real problem. A lot of open source people don't think about this because, well, I just deliver, it's not my problem, but I think that's something we in general have to think about, and before we deliver, when we program. So this is another kind of harmlessness. Before, the harmlessness was the input cannot produce unexpected outcomes, but now the program itself can produce that, and that's the problem nowadays. And the topic about sandboxing is preventing programs from doing bad things. So the PC can burn calculation time, AWK can do other things, and GNU AWK can open sockets for no reason. So AWK can write in the OS system, but I have that read-only mounted, so it's not a problem. But now this again is not harmless. Bash can also open sockets. I don't know how many of you knew that. Okay, so this goes further, of course. After AWK came Perl, and Perl can do eval And that is one of the most terrible things you can have in an OS. And you can also look at browsers, of course. Let's look at Netscape. Netscape had the choice between useful and harmless several times and always chose useful. I don't know who remembers the Flash plugin, but before that everyone had the Real Player and the Acrobat plugin that used to exist, and all of that was shit because that was all native code that could do everything the OS could do. So that was very useful, but it was also very dangerous. And that was a choice they made. So the actual goal is to make the programmers amongst you aware that this is a real problem and what such a program can do. So the next iteration was we do everything in JavaScript. That looked better at first, but JavaScript then was running with enough rights and privileges to do